Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. So today we are going to be looking at octal and hexadecimal conversions. So there are around 6 types where we have, but in this video we have 2. That's basically because we have covered the others on other videos, like binary conversions, decimal conversions. So you might want to check those videos out. The links will be in the description so that you may understand how we convert octal to binary and binary to octal, and also octal to decimal and decimal to octals. Also for hexadecimal to binary, and binary to hexadecimal, and also hexadecimal to decimal, and decimal to hexadecimal. So in this video we're going to start with octal to hexadecimal. So as you can see, I have taken a question here where we are being asked in octal to hexadecimal conversion to convert 4732, which is in octal, to its hexadecimal. So when you are being told to convert an octal to hexadecimal, the first thing you want to note is that you can't go directly from octal to hexadecimal. You have to first of all go through the binary, and then of course go to hexadecimal. That's why I have recommended the videos for the binary and decimal conversions. The links will be down in the description. So we want to take the this number. Of course I have also explained in those videos on how we actually go by going from octal to hexadecimal, and that's by dividing each and every number and taking it individually, also putting it in the base of 2 because we are going to binary and 2 is the base of the binary. So we will have the first number is 4, where we will be dividing by 2. 2 will go into 4 2 times, leaving a remainder of 0, and then 2 will go into 2 one time, leaving a remainder of 0. And of course, since this number is greater than the one we are dividing with, it always goes into the number 0 times, and then the number becomes a remainder. Of course, I have also explained in other earlier videos in our channel that when we are basically picking the binaries from the division algorithm method, we just pick the remainders from bottom to the top. So we'll just on our second number is 7. I will have 7 divided by 2 will be 3 remainder 1, and then 3 divided by 2 will be 1 remainder 1, and of course 2 will go into 1 0 times, leaving a remainder of 1. And of course for 3 I will have 2 going into 3 in one time, leaving a remainder of 1, and then 2 will go into 1, of course 0 times, leaving a remainder of 1. And on 2 we'll have 2 going into 2 one time, giving a remainder of 0, and then 2 will go into 1 0 times, giving a remainder of 1. So you just want to come and arrange the binary bits for each and every number down here, and you can see for 4 we have 1 0 0, and then we have for 7 we have 1 1 1, and then for 3 we have 1 1, and for 2 we have 1 0. But as I have said and explained in those videos that I have recommended above, that you want to note that 1 octal digit is actually equivalent to 3 binary bits, which means you can't work with the bits for a number which are not 3. And you can see in this situation we have 3 having 2 bits, only 1 and 1, and 2 having 2 bits, only 1 and 0. So in order to make them 3, we just add zeros onto your left, so that we'll have for 4 S1 0 0, and then for 7 S1 1 1, and then for 3 S0 1 1, and then for 2 S0 1 0. Now after you have made them for to be 3, then you want to note that you want to come and write them down. But in this case, when you are writing them down, you want to know that since we are going to hexadecimal, then when you are picking binary to hexadecimal, you just have to divide the bits into units of 4, since that's because one hexadecimal digit is equivalent to 4 binary bits. So you're just gonna take all of these numbers and then divide them into sections of 4, so that we will have 3 sections, and then on those 3 sections we will divide to get each and every number from every section, which means for the first section we will have this number, and we are going to count from the left in order to acquire the powers, and we are going to have 0, and then of course you want to ignore the zeros since any number multiplied by 0 will be equivalent to 0, and then we have 1 2 3, which means we'll have 1 times 2 is to power 3 plus 1 times 2 is to just power 0, which will be 8 plus 1 is equals to 9. For the second section, we have of course this will be 0, which means it will be 1 times 2 is to power 0 plus of course 0 1 2 plus 1 times 2 is to power 2, then of course 3 for of course 1 times 2 is to power 3, which will be 8 plus 4, and then plus 1. Sorry, there was a mistake here. It's supposed to be 8 plus 4 and plus 1, of course, which is 13. Sorry for that. And then for the third section, we will have of course here we want to ignore the 0. We will have 0 1, of course, which means it will be 1 times 2 is to power 1, and then of course 3, of course 2 and 4, 2 and 3. Then we will have 1 times 2 is to power 3, which will be 8 plus 2, which is just 10. So you want to come and write the hexadecimal down here. Of course, for the mistake made earlier before, here we will have E, and of course if you don't understand why we actually write 13 as C and of course 10 as C when we are writing the hexadecimal, I would also recommend you watch a video. The link will be in the description. It's called the Introduction to the Number Systems. It will help you understand and of course not face any difficulties when tackling these such kind of questions. So for the second conversion and octal and hexadecimal conversion that we want to look at today is actually hexadecimal to octal conversions. So this is where we'll be taking a question asking us to convert, and of course for clarity reasons, the question where we are going to convert 9DA to base 16 on the above question. I think here we had only made a mistake on the 13 on top. Here it was actually supposed to be D, so we'll have convert 9DA is to base 16, meaning it is in hexadecimal to its octal equivalent. So we want to write the numbers in numbers and not alphabet, so that we can be able to calculate, and it's going to be 9, 13 and 10, which will be required to convert into octal. As I have said before, you cannot go direct. You have to go from hexadecimal to binary in order to come from binary to octals. That's why I am greatly recommending the videos on the binary conversions and decimal conversions, since they will help you basically on understanding whatever we are saying on this video. So so you're gonna take each and every individual number, dividing by 2, so that you can be able to go from hexadecimal to binaries. And we're gonna start with the 9, and 9 you're gonna divide by 2 to get 4 remainder 1, and then by 2 again to get 2 remainder 0, and then 2 by 2 is gonna go 1 time, giving a remainder of 0. Then 2 is gonna go into 1 0 times, giving a remainder of 1. Then for 13 we're gonna have 2 into 13, which will give us 6 remainder 1, and then 2 into 6 will give us 3 remainder 0, and then 2 is to 3 will give us 1 remainder 1, and then 2 is to 1 will give us 0 remainder 1. And now of course for 10 we'll have 2 into 10, which will give us 5 remainder 0, and then 2 for 5 will give us 2 remainder 1, and then for 2 will give us 1 remainder 0, and then for 2 into 1 will give us 0, will go in 0 times, leaving a remainder of 0. Of course, I have said before, when using the division algorithm method, you take the binaries from the remainders, bottom going upward. So we want to take them and come and write them here. For 9 you can see we have 1 0 0 1, and then for 13 we have 1 1 0 1, and then for 10 we have 1 0 1 0. So of course, after you have written them like this, you want to remember that they are in hexadecimal to binary form, which means that the one hexadecimal digit is equivalent to 4 binary bits, and you don't because you want to convert them of course to octals, then you have to divide them into 3 into sections that contains 3 binary bits, and that's because in octal one octal digit equivalent to 3 binary bits. So we're gonna divide these numbers into sections of actually that contain 3 bits, and we're gonna have 4 sections, then convert each and every section in order to acquire the number in the section. So we are gonna come here and start with the first section. So we are not gonna include the zeros. That's because any number multiplied by 0 is actually just 0. So we're gonna have 0 1 2, and then we'll have 1 times 2 is to power 2, which will just be 4 for the first section. Then for the second section we will have 1 2 3, which means it will be 1 times 2 is to power 2, and then we'll have 0 1 2, which means it will be 1 times 2 is to power 2, and then plus 1 times 2 is to power 1, and plus 1 times 2 is to power 0, which will just be 4 plus 2 plus 1, which is equals to 7. Then for the third section we'll have 0 1 and then 2, which means we'll just have 1 times 2 is to power 1, and then plus 1 times 2 is to power 0, which will just be 2 plus 1 is equals to 3. And then for the fourth section we have 0 1, which means we just have 1 times 2 is to power 1, which will be 2. Now you want to just come and arrange the numbers in the section orders. So you will have 4 7 3 2 to base 8, which means it is in octal. Of course, for clarity reasons, you can confirm from the above question we have taken, which is this. Of course, 4 7 3 2 into base 8, putting it into hexadecimal, and so we have managed to come back to it on the hexadecimal to octal conversion, which means the method worked great. Thank you. I hope you understood. Don't forget to subscribe and hit the bell icon so that you may get notified whenever we post more mathematical solutions.